Welcome to CloudGenera's webinar focused on economics of databases in the cloud. This is the next installment in our Plan Ahead webinar series focused on better cost planning and better governance of your cloud spend. Databases in particular have been a hot topic for many of our clients as they look both to modernize their approach to analyzing and storing data, as well as consider their options of where they can best host these databases, either in the data center or in the cloud. Here's our agenda for today. We're going to go through 3 items. First, you'll hear CloudGenera's unbiased view of database total cost of ownership, unpacking the different considerations that contribute directly to costs associated with operating databases. Next, we're going to look at cloud database decisions that can dramatically impact this total cost of ownership. And specifically in this session, we're going to drill down on 2 particular areas: deployment model. So we'll go through the different types of deployment models available for databases in the cloud. And then we'll also touch on license models. Also very popular and timely topic as people are trying to get a handle, not just on their cloud spend, but on how to get the best return out of assets that they already own. And then in the last section of the webinar, we're going to unpack 3 myths of cloud database economics. And when we say myth, some of them might be true, some of them might be fictitious. And so the 3 items we're going to unpack, very common notions related to databases and economics of databases in the cloud. Is PaaS less expensive than running a database on infrastructure as a service? Next, right-sizing databases for cloud will save you money, right? Is that a true thing, or is that not a true thing? And then last, database addition, and how big of an impact will the different editions of database have on total cost of ownership? In this section, we're going to focus on visualizing database total cost of ownership. And it may surprise some folks because a lot of the marketing is about compute and about storage, but there are 5 attributes that need to be evaluated when considering a database's total cost of ownership. Of course, there's compute, which is the share of physical resources and, if applicable, virtualization software. There's, of course, storage, the type of storage, right? Think file, block, object, archival, the capacity. Of course, just like in the data center, the more capacity you consume or the more capacity you allocate as well as use, the higher your bill is going to be. And then an underappreciated area of total cost of ownership around storage is performance, both from what's allocated to achieve performance and what's utilized. So, of course, these are 2 main contributors to database TCO, but the 3 commonly underrepresented but very important aspects of database total cost of ownership are networking. As more of these database workloads are either organically being created in the cloud or they're being migrated to cloud, networking, as you'll see in the next few slides, has a big impact on total cost of ownership. And specifically, egress, bandwidth, and throughput. Those are 3 key elements that can contribute significantly database total cost of ownership. A 4th element, software licensing. We can't forget about the fact that these databases have to be licensed if they're commercial products like Oracle or SQL Server as examples. And depending on the deployment model, you also have to take into account operating system. And those costs must be contemplated when assessing the total cost of ownership for database. And last, the labor. The labor associated with hardware, the labor associated with storage. And so when we say hardware, we're speaking to compute infrastructure, storage infrastructure, network infrastructure, operating system, and then, of course, administering the database itself. Depending on how and where a database is deployed, each of these items could contribute to the total cost. Next, to help visualize how these different costs contribute to the overall total cost of ownership of a database workload, we're going to focus on a sample workload profile. Specifically, we're going to look at a SQL Server workload in a very common configuration, clustered configuration with 8 vCPUs and 16 gigs of RAM. It has 5 terabytes of storage. In this case, it's block storage. And it's really a general purpose type of database. So not a highly specialized workload that requires lots of IOPS, just 1,000 IOPS configured. And then also as a part of this workload profile, we're considering firewall, so secure access to the database, load balancer, a way to distribute load and achieve higher availability in this cluster database configuration. And then 10,000 gigs of egress on a monthly basis. So the data that leaves the server or the network of servers that are co-located together. And that data goes to some other location outside of that region, if you want to think of it that way. And then along with this sample workload profile and its capacity and configuration, we've modeled sample costs. And so across the board, we're leveraging industry average rates for server, platform, operating system, and database administration. For on-premises, we're taking an average of a common x86 server configuration and an industry average of costs associated with VMware and running virtualized workloads on that server configuration. We've taken some industry average, again, costs, not to be biased to one provider, around block storage at the, kind of this general purpose performance level that we've discussed. And then we've also leveraged an industry average costing for facilities. So think for this database workload, what's its small fractional share of space, power, and cooling? And the annual total cost of ownership for that configuration using CloudGenera's industry average cost model is $42,127 a year. And how we got there was taking any of those capital expenditures to buy the software and the hardware and depreciating those over 5 years, and then annualizing the contribution of labor to get to that ultimate number of 42,127. Alongside that, we created a cost model for the cloud to support the SQL Server workload. And again, with a goal to not bias towards one provider or the other, we've created an average cost of best fit infrastructure across what Amazon, Azure, and Google could offer independently. Because the goal of this exercise isn't to see this database best in one provider or the other. It's to unpack how do these different elements that we talked about in the last slide contribute to total cost of ownership. And you'll see by design that the annual TCO of the cloud providers is $43,004, less than a 2% delta between on-prem. And why this is important is because it sets the foundation of being able to compare how is data center total cost of ownership for a database different from cloud. And let's take a look at that. This slide visualizes the percentage of cost that's attributed to the different aspects of database total cost of ownership that we've discussed so far. Something to observe up front. On-premises cost for compute and storage tend to be higher than the comparable equivalent infrastructure services in the cloud. And let's speak to why that is, right? Incentive drives behavior. 6 of the 10 richest people in the world are associated with database and searching of large data sets. Amazon, Microsoft, Google, they are all very motivated to get your data in their venue. And that's not a good thing or a bad thing, but it's just something to pay attention to. And as it relates to networking, you can see the incentive to drive behavior really showcased. The fractional share of a network infrastructure to support a database workload inside a data center is significantly less than the comparable cost to support this, again, generic kind of general purpose workload that we're using as an illustration. And so while these numbers aren't absolutes, make no mistake, there's a reason why the providers are charging much more to get your data out of their venues. They want to incentivize you to put as many workloads in that venue as possible. So where in the data center, some of these costs have been normalized over decades of consumption of database software and the technology that supports it. In the cloud, they're not the incumbent. And so they're being very aggressive with their pricing, both to capture your workload and then also to make sure that the other workloads that connect to the database, there's a financial justification to put them in the cloud as well. So when you're doing your planning around databases, when you're thinking about total cost of ownership, that's why it's so important to really understand what are the things that are going to have the greatest contribution to your total cost of ownership. Software licensing, that's the next thing we'll hit. Observe how software licensing in the cloud is actually more expensive than software licensing on-prem. This speaks to what we see across the industry, not in this just this general purpose example. We see the enterprise itself has a lot of purchasing power and a lot of history in getting discounting around the software that they use. And directionally, the cloud is going to be more expensive because those cloud providers aren't going to pass along the software without a markup. They need to make profit on that too. And so sometimes it's not easy to unpack this when you get a quote from the cloud versus a quote from the data center, which is the reason we're going through this illustration in the webinar today. Last thing to highlight, labor. Hopefully it's not a surprise that the automation afforded by cloud versus traditional data center. And when I say traditional data center, we're talking about non-converged infrastructure, moving to hyper-converged infrastructure operations, but not the as-a-service model that is prevalent in cloud today. This savings going from 10% total cost of ownership contribution for a database to 5.6, it's really about that hardware administration that the cloud providers are taking on for you. And it's about some of the ways that they're able to reduce the administration of the infrastructure outside of hardware underneath the database. Now let's move into the next section. And we're going to talk about costs you need to consider and how your decisions will have an impact on the total cost of ownership of your databases. First, we're going to talk about deployment models. Deployment models can impact a database's TCO by up to 20%. As background, cloud offers multi-tenant. This is, in essence, the default in the cloud, where your workload runs alongside other organizations' workloads. Every major cloud provider provides this as an option. Again, it's the default. Then there's this notion of dedicated infrastructure, where the resources are shared only within your organization. And each of the major providers now provides this notion of dedicated hosts that you could put your database workloads on. Amazon has an even greater level of maturity. They offer this notion of dedicated instances. And what it means is they'll give you a guarantee that your workload will only run on servers that are tied to your account. And so not even other workloads in your organization could share that capacity. They give you much more fine-grained control when wanting to deploy databases in a dedicated versus a shared model. And the last offering we'll talk about that's available from cloud providers is this notion of a regulated offer, where the resources are designed to host highly sensitive data and highly regulated workloads. This is predominantly for the US public sector. And today, there are offerings from Amazon and Azure. And soon will be offerings from Google in this space. And so the key takeaway here is that different database applications are going to require different deployment models. And each of these different tiers, if you want to think of it, of offerings, come at different price points. And so it's really important when trying to unpack and understand the total cost of ownership of your database applications to document the sensitivity of the data being processed and the compliance, the privacy, the regulatory posture that your organization needs to take. And that will help guide you to whether or not you need some form of dedicated or highly regulated infrastructure above and beyond the shared offerings. Now, let's take a look at the impact of this deployment model decision on your total cost of ownership. In this example, we're looking at scorecards that come out of the CloudGenera FinOps platform. And these scorecards help you compare 4 different Amazon deployment models. We're looking at 3-year reserve pricing across the board. And on the left, what you see is the pricing for shared infrastructure. And so Amazon offers both shared in an unregulated deployment model, as well as a shared GovCloud deployment model. And what you can see here is that the cost delta is pretty significant, right? If you have a regulated workload that needs to be in GovCloud versus a workload that you're able to run in an unregulated environment, that's a $10,000 delta on a roughly $40,000 workload. We're using a SQL Server standard license model with a clustered 8 vCPU, 16 gig of RAM configuration, as well as 5 terabytes of storage, 1,000 IOPS, and then the associated networking services that we project will be needed. Look at shared versus dedicated. It's almost the exact same story, right? Using dedicated infrastructure in an unregulated environment versus using dedicated infrastructure in a regulated or GovCloud offering, it's about a $10,000 jump. And so again, not an insignificant expenditure, over 10%. Last thing to call out in this deployment model decision is the delta between shared and dedicated itself. It's actually not that great of a jump, right? 41,826 total cost of ownership for shared, 42,175 total cost of ownership for 3-year reserved, dedicated. So that's a less than 5% total cost of ownership jump in Amazon's offer, where they'll allow you to leverage a dedicated instance tied to your account. So again, not a huge impact to TCO to be able to achieve that additional level of comfort, not sharing resources in a multi-tenant environment. Now let's talk about license model decisions. This is going to be a bigger impact to TCO. While deployment model could impact TCO of a database by up to 20%, license model could impact TCO by up to 50%. So as background, cloud offers on demand, again, kind of the default mode intended for pay for use. All of the providers offer some notion of reserved, right? Google calls it committed use. The other providers call it reserved. And the key thing to know about reserved licensing for your databases is you're committing use of a service. You may be able to repurpose that committed use to another application. You're binding yourself typically to a service in the providers. Conversely, this notion of a savings plan is where you're committing yourself to a level of spend. So each of these options will be available to you as an application owner of a database. There's also an additional decision, which is to purchase new software for your workload or bring a license you own, commonly called BYOL, in the market. And so kind of what's the key insight here around license model decisions? And it speaks to the fact that software licensing, as a general rule, is a larger percentage of your total cost of running a database in the cloud versus the data center. Looking at just Amazon and Azure as examples, the markup, the difference between bring your own license and purchase a new one, for a Windows operating system, that could be up to 120%, depending on which of the hundreds of configurations Amazon has for running Windows. In Azure, a little bit surprisingly, it could be up to 153% markup, above and beyond leveraging their Azure hybrid benefit program and leveraging, a license that you already own. Look at SQL Server. SQL Server in Amazon could be up to 692% markup above and beyond the base infrastructure that Amazon offers. Where in Azure, 57.5%. This speaks to that macro level trend of what's going on with database workloads in the cloud. Microsoft in particular is getting very aggressive to get as much of that SQL Server estate that's in the data center running in Azure as possible. Because they know that if they can get the data and they can get the database there and they can provide you an incentive to do that, and clear jumping off the page, an incentive to do it with them, as opposed to, Amazon doesn't have as aggressive of an ability to discount that SQL Server software. This is how those cloud providers are working to win the war and to get the data, because they know that the applications will be built around your database. So kind of some cool insights based upon CloudGenera's market research and what we know from our data service that has this real-time view into the market. And so again, selecting the right license model for your database application, hopefully you see this, it can be complicated. Not only do you have the different licensing options of on-demand, reserve, and savings plans, you also have this other dimension of figuring out, do you have licensing that you could reuse? And as you're seeing here in the table, that could have a significant impact on the overall total cost of ownership of your database. So by documenting how long your database is going to run, which will help you determine, which of those pay for use versus committed use models make sense for you, and researching your ability to reuse either the operating system or the database software licensing, or both, can reduce your TCO by up to 50% in the cloud. Here's an illustration comparing 3 different Google license models. And you can see here that Google 3-year committed use offers a $39,000 total cost of ownership for the SQL Server clustered workload that we've been talking about. If you move from 3-year committed use to 1 year, in this use case, that's an increase of 2% total cost of ownership. If you move from 1 year to on-demand, 6% delta in total cost of ownership. Some who are attending and are familiar with public cloud will say, hey, that's not consistent with what's advertised by these public cloud providers with regards to the savings. The detail you're missing, if that's surprising to you, is that when you commit to use, whether it's the Google model or the Amazon Reserve model or the Microsoft model, those discounts typically are only on the compute. They don't carry over to the network, to the storage. Of course, they don't impact your labor. And they're not going to impact the software licensing expense. Compute in the cloud could be as little as 4% of the total cost of ownership of a database. So from a FinOps mindset, committing to long-term use based upon the cost of your capital as an organization may not be the best option. Now, this analysis we just walked through was bring your own license. What happens if you need to buy the license? That cost for 3-year committed use when you buy your own license versus the cost when you've already bought the license and you're bringing it with you, purchasing it again will increase the total cost of ownership by 13%. That's a shift from public cloud has a business case, regardless of the license model, to this workload might be better positioned to stay in the data center. And so again, this is why the analysis around your database applications to the license model is so important. Being able to repurpose Windows operating system, being able to repurpose and reuse that SQL Server license could be the difference between a future cost that's less than or greater than the cost to run it in a data center today. Now, we're going to focus on unpacking 3 myths of database cloud economics. First myth, PaaS is less expensive than running IaaS. So here's the myth. This PaaS alternative for databases, as an example, which is what we're focusing on today, is going to be less expensive to run in the cloud because it's all automated. Here's the reality. PaaS alternatives do eliminate labor. And that labor is associated with supporting your operating system, right? All the patching, all the upgrades, right? That's now encapsulated by the cloud provider. They do that for you. You don't worry about it. They also take on some of the database administration, but it's the aspect of database administration that ties to how the database runs in the infrastructure. It's not taking away the need to support the database application, which is another part of the database's total cost of ownership. Here's something not a lot of people know. Again, it's an insight that comes from CloudGenera's data service. The markup for PaaS, as compared to the equivalent infrastructure-based services, can be between 20 and 50% greater. So for you to save money with PaaS, that's really going to be determined by the cost of your labor. As a general rule, PaaS is going to be less expensive when the takeout of labor is greater than 50% of the PaaS cost. That's the safest model. Now, of course, pricing will vary in the market. It could be closer to that 20%. That's usually for the smaller database workloads. But, in terms of a myth, you got to keep in mind that there will be use cases where you can save money with PaaS, and that's a great thing. But it's not a panacea. It's not going to be for every workload, right? There are infrastructure templates that come with database software pre-configured that will ease administration and support of database workloads that are very cost competitive to PaaS. And that's applicable both to bring your own license, as well as the model where you're purchasing the license again in the cloud. But again, you think the PaaS is free? No, there's pretty significant markup that's charged by the providers for that convenience. Now, that said, before we get into a cost comparison of PaaS, you can have other reasons to leverage PaaS. Could be about productivity, could be about reduced risk within an organization, and those are all still valid. But the purpose here in terms of the economics of databases is that, it's not always going to be less expensive. That said, here's the example using the sample workload of SQL Server Standard Cluster with 8 vCPU and 16 gigs of RAM, 5 terabytes of storage, and associated networking services. Here you can see that PaaS represents a 7% savings over infrastructure as a service. And you can see in the CloudGenera scorecarding that workload, that 8x16 workload, maps to a particular node type in Azure for PaaS, a Gen 5 GP8. The most comparable infrastructure to support that workload was Azure's F8 SV2. So what CloudGenera's engine does is it automates that process of selecting the best fit, and then it enables comparisons such as this for the FinOps professional. So you can see like the cost that would carry over if you were going to acquire a license or bring it with you. You could see the lowest cost available for infrastructure. And then you can see the labor that carries over. So again, a 7% savings in this particular use case for PaaS. Now, let's unpack another cloud myth. Right-sizing databases for cloud will save you money. There are many purveyors of cloud, and we're not focusing just on the cloud providers themselves. They tend to be pretty truthful when you speak to the right knowledgeable person. But many people who are hyping cloud in the ecosystem claim that right-sizing databases for cloud is going to save an organization money. Here's a reality. In practice, we know that there are significant expenses associated with database licensing. As a result, organizations tend to be super efficient in the utilization of database environments. Recent experience suggests these environments run anywhere from 85 to 90% utilized. And even when a right-sizing opportunity exists, if the database workload is associated with a commercial shelf off the application, that vendor may have a minimum supported configuration. And a business may not want to take on the risk, thereby making that right-sizing opportunity something that isn't actionable. But let's say we did want to go down this path, and we recognize that we have highly utilized infrastructure, but there's a little bit of headroom. And so the example we're going to walk through is a database workload where 95th percentile usage is about 90%. right? Peak usage is about 92%. On average, it's using about 83% of the CPU. And then the same database workload, the 95th percentile in RAM is 94%. Peak RAM is 95%. Average is 72. So there might be a little bit of room to pull out CPU and memory, but at a pretty significant risk, right? You take yourself to almost full utilization. And so if you have an unexpected spike, that could be bad for business. But if there is this ability to right size, we'd like to know. Here's the impact of right sizing a database. If we agree that those databases tend to be very highly utilized, looking at an 8x16 versus trying to claw back a little bit of CPU and a little bit of memory, it's actually going to have no impact on what would be recommended to consume for the workload in the cloud. And so be very wary of anyone pushing for savings through right sizing of database workloads. While right sizing may be a great opportunity for web servers, file servers, it's typically not the best solution for a production database workload. Now, let's unpack another myth of cloud. Database addition has a significant impact on TCO. This one, it's commonly understood that prices vary significantly based upon the addition of the database that you're running. This is not unique to one database software platform versus another. It is believed that database addition will have a significant impact on TCO of databases in the cloud. And that's true. The reality is, just like in the data center, the software addition has a significant impact on the TCO of a database application in the cloud. The scalability, availability, and reliability requirements of your database, these are critical items that need to be understood going in, because they're going to dictate the addition that you require. So building off that SQL Server example, an enterprise, a standard, and a web edition are available. In our example today, we focus mainly on the standard edition. But let's unpack what the total cost of ownership delta is based upon an organization's need to leverage different editions of SQL Server. Leveraging the CloudGenera engine, we've run scorecards that compare the TCO impact of database edition. And what you can see is that when you compare the costs associated with the different SQL Server editions, enterprise is 6.2 times the cost of the more entry-level web edition. Standard is 2.3 times the cost of the web edition. And so again, the key deterministic factor here is about scale, and it's about availability. And then, for some providers, it may also be functional feature set, but ensuring that your organization is aligning the workload's requirements with the minimal addition that will support those requirements is critical. It could be the difference between doubling or taking your bill 6 times what it needs to be. And now the cloud has made consumption of tech as simple as drop down and click. Is really important to make sure your organization's educated and knows that this addition could be a big swing in total cost of ownership. That concludes CloudGenera's webinar on database total cost of ownership. In summary, to truly understand the economics of running a database in the cloud, organizations have to evaluate more than just compute and storage. You need to understand network, you need to understand software, and you need to understand labor requirements. And specifically as it relates to software, you need to be mindful of the license model and the deployment model that aligns to the needs of your database workload. That's going to have a significant impact on database total cost of ownership. And lastly, selecting the appropriate addition for your application is going to have a very large impact on TCO. But the PaaS alternatives and the database right sizing, they're unlikely to contribute significantly to TCO benefits. And again, PaaS may be justified by productivity. It may be justified by reduced risk. There are several examples of where that's the case, especially if you've accumulated technical debt around an operating system. But rarely is it going to be the thing that moves the needle on TCO. So with that, we're going to pause and open it up for any questions the audience might have.
Hey, Brian, I got a question over chat already, and certainly anyone's welcome to send chats. The question is, in the slide comparing on-prem to cloud costs, are those numbers absolute, and how are those percentages determined?
Yeah, so first, those numbers are not absolute. That's an illustration to help showcase the insight that CloudGenera has around total cost of ownership. That compute and storage tend to be less expensive at a unit rate level in the cloud, but the networking and the software costs tend to be significantly more. So don't think of that as absolute. Think of that as something that's directional, but built on real world data, right? Built on real industry average cost for running a database workload in a data center versus the true cost to run that same database workload in the cloud. But mileage will vary, right, based upon the absolute requirements of a database workload. And that really speaks to the importance of having a flexible model where you can quickly evaluate different requirements for networking and for storage and for compute in one place, kind of like CloudGenera's cost planner.
Yeah, this is John. Just a quick question on those numbers and in regards to kind of high availability, especially for database environments.
Oh, excellent. Yeah.
Yeah, just, wanted to see if that was something that was taken into account, multi-zone or regions and things of that nature. So, I mean, that's cost.
Yeah. So John, I love that question because availability comes at many layers. So one thing built into that cost model was a clustered configuration, but it would be only in a single availability zone. Of course, mission critical database workloads would benefit from replication of data to other regions, to other zones, and to have capacity available in either an active-active or passive-active type configurations. Active-active in the cloud doubles the bill. No different. Like sometimes people advertise that high availability in the cloud is going to be a lot less expensive than high availability in the data center. Our data shows with empirical proof, it's double, right? So you look at multi-AZ configuration for platform as a service configuration, pick either, like Amazon has it almost like a checkbox. When you unpack the true costs, it's double. So that's for IaaS, that's for PaaS, it's double. Azure's a little bit different in that you have to architect high availability in their cloud. It's not like a checkbox, like I picked a multi-AZ and now Amazon's doing it under the scenes for me. But still, like when you break down what you need to do, you got to replicate that storage and they're going to charge you for that storage. So it's going to be double. There are also constraints, something to know about highly available data center. When you do those highly available configurations and something like an Azure in particular, they mandate you stay, and Amazon does this too, by the way, at the same service tier, at the same service level. So if you think you're going to be cute and kind of like this is something we always used to do in the data center was, well, maybe we only need 70% of the capacity in a recovery. We're not ready to pay for 100. You don't get that option in the cloud. You got to go like for like service capability. They don't let you play the game that, some of us who are kind of old at this and have played some tricks to fit within the budget. Not able to do that in the cloud. But great question, John. And it's something that we see a lot related to database workloads. The other one I didn't touch on, and hopefully I don't steal anybody's thunder, is we didn't talk a lot about IOPS. This is a critical consideration, right? We talked about performance. It wasn't that we didn't discuss it, but we didn't highlight it. When you get to higher levels of IOPS, many of these cloud offerings get exponentially more expensive. And there are cool things that companies like NetApp are doing in the cloud with some of their offerings to bring some of this higher performance at an affordable rate. Not to completely give a shout out, but John gave a great question. You know, so I think some of the economics that will change over time, but right now, that other aspect, not just of availability, but of performance and reliability that you get from higher end storage offerings. When you move from general purpose to the premium offers in the cloud, right now, that's a very significant price jump, where multi-cloud or hybrid cloud tends to be much more economically feasible.
Great, thank you. Yeah, good stuff.
Hey, Brian. Hey, Brian, one thing I wanted to bring up too on the PaaS front is a lot of times what I've seen is when you decouple the, you know, say you want to move your database engine into PaaS, you have to decouple a lot of things out of, like, say, reporting or other functions that you're traditionally used to doing from an IaaS perspective that introduce additional, I call it additional services and or additional labor cost, because it's now an additional thing that you have to manage. And so just wanted to bring that up.
Yeah, Brian, and we'll expound upon that a little bit. So what CloudGenera's data shows from the clients that leverage our platform to optimize their spend is that a large number of database applications have dependencies inside the operating system. And that's what Brian's alluding to. That could disqualify a workload from qualifying for PaaS. So if you're trying to do a web application on the cheap and you got .NET installed right along SQL Server, you can't do that in PaaS. You'll need to take that .NET workload, deploy another VM for it, make a proper connection to the database that would then be configured as PaaS. There are also many commercial off-the-shelf applications that leverage feature sets in the databases that are kind of like it's like a programming interface, and it will kick down to the operating system, do a thing, and then come back into the database. That will also disqualify your database application. So in the vetting for PaaS, above and beyond the economics of will it make sense financially, there's definitely a set of criteria that our engine looks at specifically to see, is this even a viable candidate? Because the economics could get out of control if you've got 3 or 4 little microservices running on the same box of the database, and then now you're having to build out additional infrastructure to support that. It makes that business case for PaaS even harder.
Got it. Thanks, Brian.
Yeah, thanks, Brian. Okay, team,
Yeah,
time for another question.
yeah, quick question if you have time. And so I think you did a really good job about laying out how complex it is for the different kind of pricing aspects and things. And we've definitely, you know, kind of observed that. But, you know, so one question is like, if you had a slide on, or if you could just spend 30 seconds, this is like, I think each of these things kind of has their own kind of use case. And if you guys had kind of like an official kind of position or slide or something on kind of like the recommended like use cases for kind of each of the database that you recommended, I'd love to take a look at it.
Yeah, I think, you know, John, probably the best way to accomplish that, I'll bring up another slide, is because this is so variable, static analysis is great for kind of illustration, but it doesn't help enable the greater learning, right? The greater, if you think of FinOps discipline, the greater informing of a business of the different considerations. So one of the things available is the opportunity to leverage some of our utilities to run through these models. And so we have a portal that we're gonna load some of these database examples that we walk through, but make it more interactive. So you could kind of manipulate the scale and kind of, you know, maybe change some of the requirements around security and availability and surf the different providers. So that's available on CloudGenera.com. And then there's also the ability, if you want to go a little bit deeper, to have a free trial to our cost planner product, which would allow you to kind of surf the different providers and maybe even some on-premises alternatives. And, you know, you can configure different workloads, different characteristics. But if those two don't meet your needs, we'll be happy to follow up and share some additional collateral that we have that can go a little bit deeper into the use cases we covered today.
Great, thank you. I really appreciate that. And yeah, no, I do have access.
Awesome. All right, any other questions, team, before we wrap today?
One more in chat. Yeah, I've got, does CloudGenera consider database egress fees?
Yes, so that was actually one of the things that was modeled in the sample workload profile. 10,000 gigs of egress monthly was one of the things that was in that model. And it's one of the items that contributed to that significant growth in network expense. And the illustration we showed today of where the percentages lay out, data center and cloud, total cost of ownership. It was also one of the reasons why reserve licensing didn't have as big of a discount impact as one might expect for the database workload. So yes, egress is absolutely one of the things that we take into account. And it's part of that networking component of a database's total cost of ownership. Okay, well, team, again, thank you so much for your participation today. We're going to post this up on the website here in a couple of weeks. And if you found it valuable, please feel free to share with your colleagues and your friends. You know, our goal of these sessions is to share knowledge that we're getting out of everyday use of the CloudGenera platform. And your questions and your feedback are very much appreciated, and look forward to joining you and other folks again soon on our next cost planning webinar.